This is SpaceTime, Series 24, Episode 145. Coming up on SpaceTime, NASA's Ingenuity soars through the alien skies of the red planet Mars yet again. Blue Origin launches its third space tourism flight. And China undertakes its 50th launch for the year, and yes, it's another spy satellite mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Ingenuity rotocopter has undertaken its 18th flight over the surface of the red planet. The 125-second journey covered some 230 metres as the 1.8-kilogram helicopter continued making its way back to its original starting point, where the Mars Perseverance rover first landed in Jezero crater back in mid-February. The flight, which reached speeds of 9 kilometres per hour, further tested the helicopter's ability to fly in the warmer summertime weather conditions which are now bathing the Martian northern hemisphere. You see, warmer weather means the air is less dense, and that forces mission managers at the Jet Propulsion Laboratory in Pasadena, California, to increase the chopper's rotor speeds in order to lift off and fly. The tissue box-sized helicopter was originally designed to only fly under colder conditions, and for just a few minutes of total airtime, just long enough to prove that a powered aircraft could operate on another world. They were originally hoping to get 5 flights out of the chopper, so achieving their 18th flight was beyond their wildest dreams. Ingenuity's total flight time on Mars has now exceeded 32 minutes, visiting 10 different locations. The only serious issues so far have been a timestamp glitch which interrupted the flow of navigation images to Ingenuity's onboard computer that occurred back during Flight 6 on May the 23rd, and a sudden drop-off in communications during landing on Flight 17 earlier this month. That was caused by local terrain blocking out the signal. Mission managers are using Ingenuity to scout out ahead of Perseverance as the pair continue exploring the dried-up River Delta region in search of signs of past microbial life on the red planet. This is SpaceTime. Still to come, Blue Origin launches its third space tourism flight, and China undertakes its 400th Long March rocket launch. All that and more still to come on SpaceTime. Blue Origin has launched its third space tourism flight into the clear blue skies above West Texas. The latest New Shepard flight, numbered NS-19, quickly climbed past the 100-kilometre high Kármán line, marking the official start of space, and then returned safely back to the Earth, taking just 11 minutes for the round trip. Among the 6 passengers aboard for the flight was Laura Shepard Churchley, whose father was Alan Shepard. He was the first American to travel in space back in 1961, undertaking a 15-minute suborbital flight aboard a Mercury Redstone capsule. The new Shepard launch system is named in his honor.
Okay, we are in our auto sequence. The bridge is retracting to its flight configuration. At this time, we're also going to be pressurizing the tanks.
And of course, our crew is seeing, hearing, and feeling all of this on board the capsule.
Yes, absolutely. Those aft fins down here at the base of the rocket, they help to direct the vehicle on ascent and descent, so commanding a profile there and making sure that it's tracking. The engine nozzle here gimbaling. The engine will help to maneuver the rocket as well, especially right there before landing.
Ladies and gentlemen, we are 30 seconds. It is time to launch this rocket. Godspeed, New Shepard. Godspeed, the original 6. Thank you so much for joining us.
-10, 9, 8, 7, 6, 5, 4, command engine start, 2, 1.
New Shepard has cleared the tower. New Shepard lifts off towards space with a full capsule of 6 humans for the very first time. We are climbing fast. We've punched through max Q. That is the point where the aerodynamic stress on the New Shepard booster is at its maximum. Our original 6 are getting the ride of their lives right now. Coming up next here in under a minute is going to be main engine cutoff, where we cut off that BE-3. Main engine cutoff of the BE-3.
The CCRCS thrusters firing, and we have confirmed separation. All right, so capsule, booster separated. Capcom Serenites will momentarily cue the astronauts to unbuckle their harnesses and start floating around the capsule.
They are in zero-G, they've practiced for this, and now it's really happening. Well, huge congratulations to all 6 crew. They have crossed that Kármán line and they became official astronauts. Outstanding. Both the crew capsule and the booster are descending. The forward fins on the New Shepard booster have deployed. That booster is on its way back to Earth first.
So those fins, when they deploy, they help to shift that center of pressure so that we have just the right aerodynamic characteristics that we want for that rocket to come in a very stable way.
Engine restart on that BE-3 confirmed. Altitude dropping fast. Sonic boom here in the studio. Hear that? Feel that for sure. That beautiful booster hover. And booster touchdown. Welcome back, New Shepard. Crew capsule on final descent back to the West Texas desert. Let's wait for that now.
All right, and there go the drogue parachutes. That's a beautiful sight. Slowing down the capsule. And there we go, the drogues lifting out the main parachutes. Looks like we have 3 beautiful parachutes there in their reef configuration. And the release, the disreef, there we go. 3 beautiful main parachutes. So while these parachutes are obviously essential in providing a gentle touchdown for the crew capsule, New Shepard also has an innovative retro thrust system. So that's on the bottom of the capsule, and that will make touchdown even smoother for the astronauts flying today.
Stand by touchdown. Stand by touchdown.
So keep in mind here, there we go. Retro thrust and touchdown.
There we have it, looking like a completely successful 3rd human flight. So at this point, our team is going to prepare those landing safety operations to recover our astronauts from the crew capsule.
So now here after touchdown, the capsule will be going through auto-safing. So the vehicle is going through some of its own procedures to vent some of the pneumatic system and turn off some of the power systems. And this is all while coordinating back with Mission Control, who will be running their own procedures to continue that safing procedure while we have our crew capsule recovery team driving out.
The flight follows 2 previous launches this year, seeing Blue Origin founder Jeff Bezos on the first flight in July, and Star Trek's William Shatner, aka James T. Kirk, captain of the Starship Enterprise, on the second one in October. This is SpaceTime. Still to come, China launches 2 more spy satellites as it continues its preparations for war. The Earth enters perihelion. A look at Sirius, the brightest star in the night skies, and the Quadrantids Meteor Shower are among the highlights of the January night skies on Skywatch. China has undertaken its 50th orbital mission for the year, with the flight also marking the 400th launch of a Long March series rocket. The payload consisted of a pair of what China euphemistically described as technology satellites used to probe the space environment, including space radiation. Now, in reality, they're actually a pair of Shenzhou 6 Group 05 electronic intelligence gathering spy satellites. They're designed to eavesdrop on the communications and signals intelligence of other countries. The launch aboard a Long March 4B rocket from the Jiuquan Satellite Launch Center in northwestern China's Inner Mongolia brings to 150 the number of spy satellites launched by Beijing since 2016. The spacecraft were placed into a 600-kilometre high sun-synchronous polar orbit. Beijing's space operations have been relentless. Since 2019, they've launched more than 100 spacecraft. And this latest launch came just 3 days after China launched 5 experimental satellites aboard a Series 1 rocket, also from Jiuquan. The Series 1 is a small solid-fueled launch vehicle designed to carry light payloads up to 350 kilograms into low Earth orbit. Days earlier, Beijing launched a new military telecommunications satellite for the People's Liberation Army. The 5,500 kilogram ChinaSat 1D was launched aboard a Long March 3B rocket from the Xichang Satellite Launch Center in southwestern China's Sichuan province. This is Space Time. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January is the first month of the year in the Julian and Gregorian calendars. The name originates in the Latin word for door. That's because January is the door to the new year and an opening to new beginnings. The month is conventionally thought of as being named after Janus, the mythical Roman god of beginnings and transitions. But according to the ancient Roman farmer's almanac, it was actually Juno who was the traditional god of January. Of course, from an astronomical point of view, January marks Earth's closest orbital position to the Sun, perihelion, which occurs about 2 weeks after the December solstice. Planets, including the Earth, don't orbit the Sun in perfect circles, but rather in ever-changing elliptical orbits. The shape of these orbits vary due to gravitational influences from other planetary objects. And in Earth's case, that especially includes the Moon, which is almost massive enough to be considered a binary partner. So, over a roughly 100,000-year cycle, Earth's orbit changes in shape from almost circular to far more elliptical. This difference is known as eccentricity, and the nearest point in Earth's orbit around the Sun is called perihelion. This year's perihelion will occur on Tuesday, January the 4th at 17:52 in the afternoon Australian Eastern Daylight Time, when the Earth will be exactly 147,105,052 kilometres from the Sun. That's 1:52 in the morning US Eastern Standard Time and 6:52 in the morning Greenwich Mean Time. Around 6 months later, and about 2 weeks after the June solstice, Earth will be at its furthest orbital position from the Sun, a location known as aphelion. Okay, let's start our tour of the January night sky by looking to the northeast, right next to the constellation Orion, where you'll see the brightest star in the night sky, the dog star Sirius. So called because it's the brightest star in the constellation Canis Major, the big dog. The name Sirius actually means scorching or brilliant, a clear reference to its spectacular brightness in the sky. As well as being one of the nearest stars to the Sun at just 8.7 light-years, it's also intrinsically bright, and almost twice as bright as the second brightest star in the night skies, Canopus. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Sirius is the fifth closest star to the Sun, and it's gradually moving closer to the solar system, so it'll steadily increase in brightness over the next 60,000 years, after which time it will begin moving away again, and it will gradually become fainter and fainter. But it will still continue to be the brightest star in Earth's night sky for at least the next 210,000 years. Sirius is a binary star system comprising a spectral type A main sequence white star called Sirius A and a small white dwarf companion Sirius B, which orbits between 8.2 and 31.5 astronomical units away from the primary star. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres. Main sequence stars are those undergoing hydrogen fusion into helium in their core. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue white stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars known are spectral type M red stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the spectral classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarfs we talked about before, which are about 75 to 80 times the mass of Jupiter, or around 0.08 solar masses. Brown dwarfs don't have enough mass to build up the sorts of temperatures and pressures in their cores needed to trigger the nuclear fusion process which makes stars like our Sun shine. Sirius A has at least twice the mass of the Sun and is about 25 times more luminous. The Sirius binary system is between 200 and 300 million years old, quite young by astronomical standards, and it originally consisted of two bright spectral type A white stars. The more massive of these two stars, Sirius B, consumed its resources and became a red giant before shedding off its outer layers and collapsing into its current state as a white dwarf around 120 million years ago. White dwarfs are stellar corpses of Sun-like stars. Stars shine by fusing the hydrogen in their core into helium. When these stars run out of hydrogen, hydrostatic equilibrium, that is the balancing act between the outwards push of nuclear energy and the inwards pull of gravity, ceases, and gravity wins, causing the star's core to dramatically contract and compress under its own enormous mass. As the star contracts, regions around the stellar core which still contain hydrogen move closer to where the core used to be, and therefore the region where pressures and temperatures allow hydrogen fusion to take place. This triggers hydrogen burning in a shell around the core, causing the star's outer layers to dramatically expand. And being further away from the core, the star's photosphere, that is its visible surface, is cooler and so looks redder. The star, now called a red giant, experiences a massive increase in stellar wind production as more and more material flows out from its gaseous envelope. Meanwhile, the increase in pressure and temperature caused by the core's contraction eventually triggers a helium flash, fusing the core helium into carbon and oxygen. While high-mass stars will fuse progressively heavier and heavier elements in their cores, low-mass stars, such as the Sun, don't contain enough mass to fuse carbon and oxygen into heavier elements, and so the fusion process ends. Eventually, the star's outer gaseous envelope drifts away as a spectacular planetary nebula. What's left behind is a super-dense white-hot stellar core about the size of the Earth called a white dwarf, which will slowly cool down over the eons of time. Our Sun will become a white dwarf in about 7 billion years from now. 5,000 years ago, the ancient Egyptians looked at Sirius and they saw it as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Anubis was later replaced in Egyptian mythology by Osiris as the lord of the underworld, and Sirius became the goddess Isis. By carefully watching Sirius's movements across the sky, the ancient Egyptians determined that it would be visible every night for 295¼ nights, followed by 70 nights of absence. And this allowed them to determine that a year was 365¼ days long. Their calculations were accurate to within 11 minutes. The helical rising of Sirius also marked the annual flooding of the River Nile in ancient Egypt and the hot, sultry dog days of summer for the ancient Greeks. In Greek mythology, Sirius was the dog star and the canine companion of Orion the hunter. Helical rising refers to the first time of the year when a star becomes visible above the eastern horizon for a brief moment just before sunrise. It's been claimed that the Dogon people in Mali in Western Africa have ancient stories describing the 50-year orbital period of Sirius and its companion white dwarf, which predate the white dwarf's discovery by modern astronomers. It's also claimed that these legends were handed to the Dogon people by ancient aquatic space travelers who told them of a third star accompanying Sirius A and B. However, a report in the journal Current Anthropology raised serious doubts about whether the stars referred to by the Dogon people were in fact Sirius A and its white dwarf companion. That's because senior Dogon claim the story actually refers to a different grouping of stars. Also, other researchers have pointed out that the Dogon could have heard about the discovery of Sirius's companion and then simply incorporated it into their mythology in 1893 when a French expedition arrived in Central West Africa to observe an April 16 total eclipse and were overheard discussing the discovery. Looking due north just above the horizon this time of year, and you'll see the bright yellowish star Capella, the brightest star in the constellation Auriga the Charioteer. Capella is the Latin term for a small female goat. The star's alternative name is Capra, which was more commonly used in classical times. Although it appears to be a single star to the unaided eye, Capella is actually a system of 4 stars in 2 binary pairs. The first pair comprises 2 bright yellow giant stars, both of which are around 2.5 times the mass of the Sun. Having exhausted their core hydrogen supplies, both stars have cooled and expanded out to become giants, moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, some 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of the Sun. Known as an aging red clump star, Capella AA is fusing helium into carbon and oxygen in its core. Capella AB is a slightly smaller but hotter subgiant, about 73 times as luminous and almost 9 times the radius of the Sun, and it's in the process of expanding out to become a red giant. The Capella system is one of the brightest sources of X-rays in the sky, thought to come primarily from the corona of the more massive giant. The second pair of stars in Capella are located about 10,000 astronomical units from the first pair. They consist of 2 faint, small, relatively cool spectral type M main sequence red dwarf stars. The 2 red dwarfs have been designated Capella H and Capella L. Now, almost directly overhead this time of year, a position in the sky known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. Located some 313 light-years away in the constellation Carina the Keel, Canopus looks incredibly bright because it is huge. It's a giant spectral type A white star, with some 10 times the mass, 71 times the diameter, and 10,000 times the luminosity of the Sun. Canopus is another bright X-ray source, also most likely produced by its corona, magnetically heated to several million Kelvin. The temperature is also likely to be stimulated by fast rotation combined with strong internal convection currents percolating through the star's outer layers. No star in our night sky closer than Canopus is more luminous than it, and it's been the brightest star in Earth's night sky during 3 different epochs over the past 4 million years. Other stars appear brighter only during relatively temporary periods, during which they're passing the solar system at much closer distances than Canopus. About 90,000 years ago, Sirius moved close enough that it appeared to be brighter in our night sky than Canopus, and as we mentioned earlier, that'll remain the case for another 210,000 years. But in 480,000 years from now, Canopus will once again be the brightest star in the night sky, and it will remain so for a period of about 510,000 years. In Greek mythology, Canopus was a helmsman and the navigator for the fleet of Menelaus, king of Sparta, which was sailing back from the Battle of Troy. Canopus is said to have died when the fleet arrived at the port of Alexandria in Egypt, and so a star which was visible on the horizon was named in his honour. Now, as we said, it's the brightest star in the constellation Carina, which represents the keel of the boat Argo, used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Pappus. Canopus forms part of the stellar association or asterism known as the False Cross, which straddles the constellations Carina and Vela the sails and is often confused with the real Southern Cross or Crux. Combined, Carina, Vela and Pappus used to form the constellation Argo Navis, representing the ship Argo skimming along the river of the Milky Way. But modern-day astronomers consider this constellation simply too big. That's because it was something like 28% bigger than the next largest constellation and had more than 160 easily visible stars. And so, in 1755, it was decided to divide Argo Navis into 3 smaller constellations, Carina, Vela and Pappus. This time of the year, the Southern Cross is upside down, low down in the southern skies during the early evening. For our listeners north of, say, Brisbane, it'll most likely be hidden by trees and buildings on the horizon during the early evening. But later on, as the Earth turns, the Southern Cross will rise above the horizon in the south-southeast for our northern listeners and appear to be lying on its left side. One of the best things about living in the southern hemisphere is that most of the brightest stars in the night sky are visible during January nights. Sirius the dog star is the brightest, followed by Canopus the navigation star. Third brightest is Alpha Centauri, the furthest of the two pointer stars pointing to the Southern Cross and the nearest star system to the Sun. The fourth and fifth brightest stars, Arcturus and Vega, aren't visible in the southern hemisphere during January. But the sixth brightest, Capella, is visible just above the northern horizon. And the seventh, Rigel, marks Orion's knee. Next in eighth place is Procyon the little dog. And ninth is Achernar at the end of the river Eridanus. Finally, there's Betelgeuse, Orion's shoulder, the 10th brightest star in the night sky. So, that's 8 of the 10 brightest stars in the night sky, all visible at once on a warm summer's evening in the southern hemisphere. January also plays host to one primary meteor shower, the Quadrantids. Most meteor showers radiate out from a recognizable constellation, like Leo's Leonids or Gemini's Geminids or Orion's Orionids. But the Quadrantids are meteors that appear to radiate out from the location of the former Quadrans Moralis constellation. In the early 1920s, the International Astronomical Union divided the sky into 88 official constellations. However, that means more than 30 other historical constellations didn't make the cut. The Quadrans Moralis area of the sky falls within the boundaries of the official constellation Bootes. The radiant point of the shower is near the Big Dipper, between the end of the handle and the quadrilateral of stars marking the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers, with up to 8 meteors per hour. They're best seen from the northern hemisphere, and unlike other meteor showers which tend to peak for at least a day or two, the Quadrantids only peak for a couple of hours. While most meteor showers are produced by the Earth passing through debris trails left behind by comets, the Quadrantids are one of only 2 meteor showers known to be produced by asteroids. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus that fragmented and broke apart centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit which extends out beyond Jupiter. The progenitor is thought to be the comet C1490Y1, which was first observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was discovered by a near-Earth asteroid telescopic survey in 2003. The only other major meteor shower associated with an asteroid are the Geminids, which occur in December and are caused by debris left behind by the asteroid 3200 Phaeton, which is also thought to be the remains of a comet. Jonathan Alley, the editor of Australian Sky and Telescope magazine, joins us now to continue the rest of our tour through the January night skies.
We'll begin with the evening sky. We're looking down to the south. We've got the Southern Cross. It's still sort of upside down more or less at the moment in the evening, low down on the southern horizon for most people. These people live in the sort of southern hemisphere, the latitudes of Sydney or so. But as the night goes on, it won't take long, and as the Earth rotates, you'll see the Southern Cross start to come up a little bit in the southeast, and by sort of late evening, it'll be on its left-hand side in the south-southeast. Now, you've got the Milky Way, which is our galaxy seen from the inside, of course. It's stretching right across the sky from south to north, and its star fields contain some super constellations and deep sky objects and things, because that's where most of the stars are that we can see. They're within the Milky Way, because when we're looking into the Milky Way, we're looking sort of into the main bulk of the galaxy. If we look at right angles to that, then we're looking out into sort of deep space. There's still lots of stars and things, but not quite as many as looking into the galaxy itself. So starting down in the south, we've got the Southern Cross, which is in the Milky Way. The official name for that constellation is Crux or Crux, if you want the correct pronunciation. And then just near there, you've got some other fantastic constellations that most people probably haven't heard of, but you've got Carina, you've got Vela and Puppis. Then you get around to Canis Major, the lesser or smaller dog. And finally, sort of following the Milky Way around, we get to constellations like Orion and Gemini and Taurus. And all of these constellations through this part of the Milky Way have just amazing star fields, star clusters, nebulae, a lot of which can be spotted actually with just a pair of binoculars, particularly the star clusters. You just need a pair of ordinary 7x50 binoculars that a lot of people have at home. But a telescope will give you a lot more detail, particularly when you're looking at things like nebulae. Now, and if you're looking seeing nebulae, which are these sort of gas clouds in space, through a small telescope, you probably want to use what's called averted vision, where you don't look directly at it. You line the telescope up on it, so it's right in the centre of your field of view, but don't look directly at it. Look off to the side a little bit, because the centre of your eye isn't very sensitive to the sort of dim light that a nebula puts out. So you want to use the sort of side of your eye. Look out the side of your eye. That's called averted vision, and that'll give you better viewing. Now, more or less directly north in the mid to late evening in January, we've got a tiny clump of stars that we've spoken about before called the Pleiades, or the Seven Sisters. There's actually about 1,000 stars in this star cluster, and they're quite a long way from Earth, but to the naked eye under dark skies, you can probably see about 6 or 7 stars. Most people will see 6 or 7 out of these 1,000 stars, thus the name Seven Sisters. Some people claim to be able to see 10 or 11 of the stars. I mean, you've got to have pretty good eyesight for that, and dark skies, and you have to let your eyes adjust to the darkness. You know, if you've come outside from inside where you've got lots of light and stuff, give yourself 20-30 minutes to get really dark adapted. And binoculars work really well on this star cluster, the Pleiades. They've got this beautiful blue glow around these stars because there's a gas cloud mixed in with the stars as well that gives them a sort of a shimmery sort of appearance that's really, really pretty. Back down the south again, high up in the south time of year, we've got these 2 galaxies that you can see with the unaided eye, as long as you don't have too much light pollution around. And these are the small and the large Magellanic Clouds. They've been famous for lots and lots of years. Astronomers find them really handy because they're the biggest nearby galaxies to us, so they can even make out individual stars in these 2 galaxies. They're that close, so they're good sort of, I don't know, what would you call them, test beds or experiment areas for studying stuff that's in other galaxies. So we're lucky down the south to be able to see these things. They don't have the equivalent of these galaxies up in the northern hemisphere, so we're really quite lucky. The most famous star in the Large Magellanic Cloud was one that exploded about 168,000 years ago, and it took that long, 168,000 years, for its light to reach us in February 1987, and it was a supernova. It was a big star that blew up, which is a supernova, and it became known as Supernova 1987A. A meaning it was the first one spotted in that year. We can't see it anymore, at least to the naked eye. It's faded a long, long time ago, but we can see its home galaxy, the Large Magellanic Cloud, with the naked eye. So when you look at that cloud, you look at that galaxy, you're too late now by about, 30-something years or so. But I remember it. I remember it in 1987. I went out and saw it. So that was the first bright supernova. It was the first supernova that was visible to the unaided eye for about 400 years. There are plenty of supernovae go off in other galaxies out there. They're spotted all the time, but they're so dim that you need big telescopes to see them. This was the first one in 400 years that was bright enough to be seen with the naked eye. And bearing in mind that it's 168,000 light years away, and we can still see it with the naked eye in a galaxy that you can just barely see from city skies. So imagine if a supernova went off in our galaxy. That would be just amazing. It would be so bright. And that's what astronomers, in every generation, astronomers for centuries have been keeping their fingers crossed that maybe one day there'll be a supernova goes off inside our galaxy, the Milky Way, and then we'll be able to have a good, effectively close-up look in astronomical terms.
And there's such a tragic story associated with the discovery of that supernova too, isn't there?
Oh, there is. Of course, everyone wants to discover these things, particularly something that only comes around every 400 years or so. And there was an astronomer, a really nice astronomer, who had been working in Australia, and he had this setup where he would had a camera set up to take photographs of the night sky automatically every night, and it would take the photographs. This is the days before digital cameras. He had to use film and developing and all that sort of thing. And during the daytime, he'd get the photos that were taken overnight and develop them and print them out and see if he could spot anything that had changed. And he would often spot little things that were going on in the night sky. This particular night, when this supernova went off, he didn't get around to doing it the next day. And I think it was the day after when he finally spotted, or later that day or something, that, wow, here is a supernova. But a couple of other people had spotted it in the meantime, and they sort of got the credit. It was a great shame, but he went on to, he's discovered lots of comets, lots of novae, lots of all sorts of things, so he's done pretty well for himself. But yeah, you've got to be either lucky or unlucky sometimes. I mean, 1 in a 400-year event, and as Maxwell Smart used to say, missed it by that much. Sorry about that, Chief. Yeah. Sorry about that. Sorry to people who don't know who Maxwell Smart is. Probably some young people don't. Anyway,
dating both of us now.
Now, look, quickly avoiding that topic and turning to the planets. Now, the big event for this month is going to be really good, but you only see it from a certain part of the world. It's actually on the 1st of January, and People in far southeastern Australia are going to be able to see this. People in other parts of the world can see other similar things other times of the year, but this one is just for us down in the far southeast of Australia. And what it's going to be is the moon is going to move in front of Mars as seen from those locations on Earth. Astronomers call this an occultation, and it's reasonably rare. It doesn't happen every year. So Mars, of course, is many, many tens of millions of kilometres away, and the moon is very close. So they're not actually near each other in space, but Mars just sort of, the moon, as it's going trundling along in its orbit, will move in front of Mars, and that's called an occultation when it blocks out the light of whatever's behind of it. So for those in Australia, if you're in the southeastern corner of the continent, so Canberra, Melbourne, Adelaide, places in between, I think Hobart might catch it, and everyone in sort of outside of that area will see like a near miss.
Yeah.
You'll see Mars just sort of go very close to the edge of the moon. The moon won't exactly cover it up. And so it should be a pretty amazing sight. The moon does cover up some of the planets from time to time, one by one. They're predictable, but there's no sort of pattern as such to it. And sometimes you're in the right part of the world, sometimes you're not. Sometimes it can be seen from the northern hemisphere, sometimes the southern hemisphere. Sometimes it might happen when you're on the day where you are is in the daylight part of Earth, and the people on the other side of the Earth, the nighttime side of Earth, will see it and you won't. So it's just the luck of the draw, really. But for those in the right spot, January the 1st, try not to miss it. And it's perfectly safe to see, too, because you're not looking at the sun or anything. It's just the moon and the planet Mars. As for the other planets, well, we've got Mercury and Venus are both very, very low on the horizon after sunset in the first week of January, and most people have actually great trouble spotting them. They're that low. So if you've got hills or buildings or trees and things in the way, they'll block the view of these two planets because they will be very low. And they're going to disappear from view for a while after that as each of them moves between the Earth and the Sun. But they will reappear low on the eastern horizon before dawn by the end of January, and they'll start to rise up above the horizon as the days go past into February. What can be seen in the evening sky during January, after sunset that is Jupiter and Saturn, at least for a while. Both of them are very bright. Jupiter's brighter than Saturn, although Saturn is still pretty bright. And like Mercury and Venus, though, Saturn's going to disappear into the glare of the sun when the sun is setting by the middle of January, so that one's going to vanish as well on us. But this time, instead of being, of course, Saturn can't go between us and the sun because it's an outer planet, so when it disappears into the sun's glare, it's on the other side of the sun. So Mercury and Venus are going to be on this side of the sun going between us, but Saturn is going to be on the other side of the sun. Jupiter is going to do the same thing soon, but not in January, but it will end the month very, very low on the western horizon as well after sunset, so it too is going to disappear from view shortly. And that leaves Mars, which is visible above the eastern horizon, though, before dawn, so you've got to be up early, you've got to be an early riser. It's fairly easy to spot, actually, due to its sort of orangey-reddish colour. There aren't too many brightish orangey-red stars, so it's a fairly easy one to spot. If you take a look on January the 30th, you'll actually see Mars with the moon close by, and below them, very, very bright, will be Venus, so they sort of make a triangle. Mars, the moon, and Venus on January 30th. That should be a really pretty sight. And coming up during the year, there are going to be all sorts of these really nice gatherings of planets and the moon in little groups of 2 or 3 or 4. So there's going to be some nice stuff to look out for during 2022.
And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.